Okay, welcome to Developers Toolbox Season 2. Bear with me for 1 second here. There we go. Okay, so we're starting a new season, and we're starting off with kind of a topic that diverges from what we were covering previously, which was automated software testing. Today we're going to be talking about generating random data using Bogus. So I've got a project that I've been working on, and the premise of this project is not super important, but it's a tool for mechanics to be able to provide home services to people with vehicles. So there's some things that I've done here that I need to cover first to kind of explain the database setup and everything before we get into the actual Bogus and what we're doing with it. So I've got I wanted to cover first, I've got this list items table. I believe I have the table design up. No, maybe not. Okay. Go ahead and pull that up. So I've got this list items table, and this is just it's a way to hierarchical or store flattened hierarchical data that's in kind of name value pair or key value pair format. So we have a list identifier for each item in here, and then the name and value of that item. And if it refers back to another item in a different list, you get the parent list ID, which refers to the list ID of the parent list and the parent value. And so to explain why this is necessary and what I'm doing with it, vehicles will have a make and model. I think everyone's kind of aware of that. So you've got the manufacturer that made the vehicle and the model of the vehicle. And so I have a list of manufacturers, right? And each of those manufacturers has one or more models that they've produced. So I've already seeded this data into the database, and we can take a look at, here it is. So the list identifier actually comes from an enum in the application. Let me see if I can pull that up real quick. I believe it's in I remember, okay. I thought I remembered list items. It's in lists, that's right, okay. Yeah, so it's just an enum. The list for makes is going to have a list ID of 0, and the list for models is going to have a list ID of 1. So we have, here's all the different kind of vehicle manufacturers, and you can see like each one of these just has a distinct value. The item ID is like a globally unique identifier for that list item, and that's just an auto incrementing integer, so pretty typical stuff. Yeah, so that's list 0, and then list 1, which starts here. I've just kind of pre-populated this with a data set I picked up from somewhere. So the as an example, the CL, whatever this is, this would be the first item in the models list, and the parent list ID of this is 0. So that means the parent list item is a make or manufacturer, and the parent value is 1. So if we look at the item in the list 0 with the value of 1, it's Acura. So that means that Acura makes the CL. So does everyone kind of understand that? Anyone have any questions on how this list items stuff is set up before we dig into the meat and potatoes of this thing? No questions? Okay, so now let's take a look at some Bogus. So I've got this. I needed to seed this database with a lot of random data for demonstration purposes, right? It's a a pretty typical requirement for if you're building a demo environment for a product or what have you. For the purposes of demonstration, a lot of times you want to have a large sample of test data that you can throw on there that doesn't expose anything sensitive and is just generic fake data that you can use for the purpose of demonstrating a system. So I wanted to do this, so I created a service class called seed data service. So this is going to be the class that has all the methods to actually seed this data into the database. So I'm using Bogus here. Bogus is a NuGet package, so you can install it through the NuGet package manager. You can .NET add package Bogus, and that will add it into your project. And then you can just use the namespace wherever you want to use it. The main class in Bogus is actually called Faker. So you'll see this Faker a lot. That's provided by the Bogus namespace. And Faker, it relies on a generic parameter to explain what it is that you're trying to fake. So just starting with the simplest, we're going to start with a simple example and then work our way into more complex ones. So the first thing that I wanted to seed is user data. So if we take a look at, let's take a look at the user table. And I'm not going to pull up the design for this, the design view, but effectively we have a user ID, which is auto-incrementing integer that uniquely identifies a user. First name, last name, email, password, a salt for their password hash, the date on which they registered, what their role is, and whether or not they're enabled. Pretty typical kind of setup for what you would consider to be a user object within the context of an application. So I need to generate some values for certain things here. So let's start off with the definition of the generator itself. So I have userGen is going to be an object that is an instance of a faker with a generic type of user. So this userGen is basically going to be our generator, and we're going to set up rules for the different properties or fields within the user class to explain to it how we want it to generate fake data. So the first rule that we want to set up is for the user's first name. We're using the imperative syntax. You can use declarative syntax as well with the Faker class and with Bogus, but I'm using the imperative syntax here. So you'll see, and this looks a lot like Fluent API. If anyone's familiar with the idea, is basically that. With Fluent API or imperative, you often will have a method that returns back the object itself that you're operating on. And the nice thing about that is it makes it really easy to chain function calls together against the same object. So you'll see we're calling .rule_for over and over again against this instance of a faker. And each one of these rule_fors just returns the faker itself so that you can chain onto it and add another function call right after. So again, we could do declarative here. We could actually just declare this gen and then repeatedly call usergen.rule_for. But just for simplicity, I have these chained together. So the rule_for function, it allows you to define a rule for a property or field. So it takes a function as its first argument. And that function has a parameter that is an instance of the object specified by the generic type. So in this case, user. So the thing that we're interested in user here is the first name field. So that's what we're specifying here. Let me just pull up this user class real quick, just so it's, I know you saw it in the database, but just so you see the corresponding EF core model, here it is. Yeah, so we've got a bunch of required fields in here, and then there's some foreign keys to other tables in the database. But the user, there's nothing that depends on, or I'm sorry, the dependencies are such that it's really easy to generate a user because the user doesn't need to have necessarily any of these other things. So that's why user is the first example we're going through here and the simplest to explain. So anyway, getting back to it though. So the rule_for, the first thing is first name, and then the second argument to rule_for is also a function, but this function takes a parameter faker f, and so this this parameter to this anonymous function, this lambda that we have here, is actually going to be what you're going to use to produce anything that Faker can produce for you most of the time. There's a couple of places where you actually have to explicitly call out Faker itself, rather than this argument to this anonymous function here, this lambda. But in this case, we're just going to use the one that's provided by the function. And there's some different classes of things. You can look at the Bogus documentation to get the full list of things that Bogus can effectively generate for you. But one of the things that they have is a name. So this will generate this is a class of things that will create a random name. So we want to create something that looks like a first name. Of course, they have a function for that. So we just call f.name.firstname, and this is going to produce a random string of text that, and we can see it does produce a string. It produces a string that looks like somebody's first name. So it will randomly pick a first name either out of a list that it has, or I'm not really sure how it works under the hood, but this will give you a random first name. And then same thing with the next rule for, we're doing last name. So the name class also has a last name function that will produce something that looks like a last name. And so we are setting a first name, we're setting a last name. Email, we want to set email on a user, and there is another class within the Faker namespace, internet, and this has a number of different functions that we can call for things that would be considered internet related. One of those is email. So this will produce, again, it produces a string that will be a random email. And there's some parameters that you can pass into this. Again, I'm going to defer you to the Bogus documentation if you want to see all the different things that you can do with this. But we can call this with this function with an empty just to generate something that looks like a random email. But if we want that email to actually look like the person's name, we can actually pass in a first name and last name here. And that will generate an email that has like a typical like first name dot last name or first initial last name or what have you, and it can do that randomly, or you can kind of define the behaviors of it. If we were going to do that, there's an overload for this anonymous function, for this lambda here, that will actually give you the instance of the user with the other rules already applied. So if we actually modify this to take f and u for user, now we can u.firstname, u.lastname to fill those parameters, and now it's going to generate an email address that contains, some semblance of the user's first name and last name. So is everyone with me so far, or is that a little bit too obtuse? We'll see more examples of using both arguments, or rather both parameters of this function a little bit later on with some of the other rules too. So for now, I'm just going to go ahead and back out that change. Anyone have any questions so far? The room is silent. Okay. All right. So we'll go ahead and move on to the next one. We want a role ID, and for these random users that I'm generating, I want them all to be part of the user's role. Let me go ahead and expand roles real quick so you can see what this looks like. So there is a user role, a mechanic role, an admin role. These are all roles within the context of my application. And actually, just so that I don't have to store these roles in like a database or something, but can still have a nice string description of them formatted, I'm using the description attribute here, which is a technique that we'll probably talk about a little bit more in depth in a future talk. But yeah, for now, just suffice it to say, we've got 3 different user roles where the integer value of a user is 0, integer value of a mechanic is 1, and integer value of an admin is 2. So for the seed data generation, I really only want to generate actual users. I don't want to generate user entries for any of the other roles yet. We'll be doing that shortly here. So you'll notice that for the second argument to my rule for call, I'm passing in, the faker the faker object, but I'm not actually using it. Instead, I'm specifying a static value here of the user's the int value of the user enum entry in the roles enum. So what this means is that for every record that gets generated in this context, the user's role ID is going to be 0 because I'm just statically specifying that role ID is going to be 0 and not using any of the faker functions for this field. Does that make sense to everyone? Okay, so you are absolutely correct. We could do it just like that as well. Yeah, since the F is not being used, and if anyone's not super familiar with lambdas, all of this is these kind of tuple or pairs of lambdas, I should say, for each of these rules. The formal way to specify this would be to wrap these in parens. But if you have a lambda that only has one argument, you can actually leave out the parentheses just as a kind of a nicety. So it's really a syntax flavor thing. If you were really being anal about following the rules and having good formatting, you would probably wrap all these in parens, and you would probably do things like ignoring parameters that you're not using, like we're doing here, as Jacob suggested. But yeah, just for the purposes of this contrived example that I have whipped up here, I'm just doing it without the parens and always passing the parameters I might be interested in using. Anyone else have any questions? Okay, so moving right along. I don't care to generate salts or passwords for any of these users that I'm generating. So same thing here, I'm just ignoring. I'm not actually using the faker instance that's being passed in. I'm just statically specifying string.empty. So for every record generated, the salt and the password fields are going to just be an empty string. The last one here is registration date. So for the date that the user registered, I want to pick a random date in the past. So the faker object has a class date or a property field, whatever you want to call it. There's date, and date contains certain functions that pertain to generating random dates. The one I'm using is past, so this will generate a date, a date time specifically in the past, so prior to the current date and time, and there are some different arguments you can pass to this. Again, I'll refer you to the documentation, but if you only pass in one parameter, it assumes it's year. So I say I want a random date and time sometime within the last year, so I pass a 1. If I wanted to go back, say 5 years, I could change this to a 5. It's going to generate dates for the last 5 years instead. And of course, you can actually leave this open to generate a random date and time anytime in the past. So yeah, if you want to constrain it, you can, but you don't have to. Kind of like what we saw with email above. But anyway, so that was the last field. We've accounted for everything in user except for the only field the only property we did not account for is user ID, and that's because that's our auto-incrementing. That's our primary key auto-incrementing integer, so we're going to let the database assign the user ID rather than manually specifying it with faker here, because that would cause us problems. So everybody with me so far? Okay, so now we've got this instance of a faker of user, and now we want to actually use it to generate some data. And the way that you do that is you just call the generate method on that instance, and you can give it a number, an integer number, and that's the number of records that will be generated by this. So we're going to generate 1,000 users, and I'm just calling this directly in. I'm using EF core here, so I've got db.user.addRange. This is my database context, and I'm using addRange because this is going to produce. The generate is going to produce a list of user because that's the generic type that we use. So when we call .generate, the output of that is going to be a list of user. If we used a different type here, it would be a list of whatever type we called for, and we'll see that again a little bit further down here. But yeah, so we're adding 1,000 of these randomly generated users to the database, and then of course we call db.savechanges. If I was being meticulous, I would wrap some try catches in here, but yeah, anyway, I'm just for simplicity, and I'm only going to be using this function a couple of times anyway. Yeah, we're basically all set. So I have, this is our seed data service. I have a seed controller that I can use. Ultimately, this will be done away with and won't be used in the actual application, and if we need to seed data, we'll do it a different way, but I just needed a quick and snappy way to make sure that this was all working the way I expected. So this is using the route /API/controller/action, which is pretty typical for a lot of the stuff that we work on. So the full path to this is going to be /API/seed/seed users. So let's go ahead and call that now. Okay, user seeded. So we now have, if we take a look at the data in the user table, we now have exactly 1,000 records, and actually we can take off this top 1,000 here. It's just the sample query generated by SQL Server Management Studio. But you can see we do have exactly 1,000 records, and we've got a series of randomly generated first names, last names, email addresses. Password and salt, as we specified, have been left blank. Role ID is always 0, as we specified. Enabled is always 0 because I don't believe we actually even specified a rule for that, which is something that might be an oversight perhaps, but we could just make that a random bool 1 or 0, or we could set them all to enabled, whatever we wanted to do there. But yeah, since we didn't specify a rule, it just defaulted to 0, so that's fine. So here's our 1,000 users, and you can see all of this, these look like pretty normal names. They've got a really kind of solid list. Yeah, so that's really all there is to it. And the registration date, you can see these are all within 1 year in the past, and there's a good mix of older or newer, so the randomness is pretty good. So we've got our sample users seeded for our demonstration. Does anyone have any other questions so far? Everyone understand the use case so far? Obviously I mentioned that this is great for being able to build a demonstration for a product, but in addition to that, whenever we circle back to and continue our series on automated software testing, we're going to talk about possibly how we could use this actually in tests too, mostly in fuzzing, which is a little bit different than what we're going to start off with, but eventually later on in the software testing series, I think we are going to talk about using Bogus and Faker to do fuzz testing, because it's also very good for that. All right, so let's go ahead and move on. I do need to make another note about the structure of the database. We have, let's see if I can find it here. We have a mechanic table. And a mechanic, if you were to look at it from a kind of a polymorphism or object-oriented perspective, a mechanic inherits from a user effectively. So all users are users. All mechanics have a user, but not all users are mechanics. So for each entry in the mechanic table, we would expect to have a corresponding entry in the user table. But it's not the case the other way around. Some users are just users, and then other users are mechanics. So this would be a one-to-one from the mechanics table back to the users table. So I wanted to generate some mechanics. So this is very similar to what we did with generating users. And in fact, I wanted to generate users, a set of users specifically that would be mechanics. So the first thing that I have to do is kind of redo my the same type of user generation that I did above. And you'll see I'm doing a lot of the same things here. So I'm specifying that first name is going to be a random first name, last name is going to be a random last name, email is going to be a random email. One thing that's different here for the role ID on the user record, instead of statically setting it to the user value of the role enum, I'm setting it to the mechanic value of the role enum. So every user that gets generated by this user gen is going to have a role ID of 1 instead of 0. Does that make sense? So again, we have the salt and password are just being set to empty strings. Our registration date, I'm once again just using any date in the past within the past year. And so that's all there is. The user gen is very similar to the one we did before. Then we've got a mechanic gen. Now this is where things start to get a little bit interesting. So let's just step through the rules for this. So let's look at the mechanic object first. That might help lend some context. Let me just rearrange my display a little bit here to make this a little bit more palatable. All right, so here's what a mechanic looks like. So they have a mechanic ID, a user ID that ties them to the user record, a phone number, a string list of qualifications, a Boolean value indicating whether they're approved or not, and a date time. That is their approved date, the date on which they were approved. So for the phone number, this is not one that we saw before, but there is a property of faker phone, which contains phone-related stuff, and we just want to generate a phone number, and you can pass in some arguments here if you want the phone number formatted in a specific way. That said, I don't really care about the format of the phone number as long as it looks like some phone number. I don't even care if it's an international number, so I'm just calling phone number with no arguments, not specifying the format here, but you could very easily do so if you want phone numbers within a specific region, if you want to constrain this to the US or even to like a specific area code, you can make rules for that. Qualifications. This is an interesting one. The qualifications, it is a string field. It's expected to be kind of a long list of things. And so for this, I'm using the property lorem of the faker class, which is a lorem ipsum generator. I'm sure probably actually speaking Skylar's language now. So with this lorem ipsum generator, I'd say I just want a paragraph. So lorem, you can generate single lines, you can generate paragraphs of text, what have you. Since I expect this qualifications field to be like a long text description, I just say I want a single paragraph. And the integer value here, it would be how many you want. So if we wanted to generate 3 paragraphs instead of 1, we pass in 3. If we wanted to do like 3 lines instead of a paragraph, we could do, there's sentence, there is lines, there's all sorts of different things. Again, you can refer back to the documentation. I'm just kind of trying to give you a basic breakdown. So just care about generating 1 paragraph here. Approved. So approved, I want it to be either true or false randomly. So I am using the f.random property. Again, first time we've used this one. And this has a function called bool, which will give you a random 1 or 0, true or false, what have you, Boolean value, right? So here's where things get even more interesting because I have this approved date field. And if the user was approved, I want to specify a date on which they were approved. But if they're not approved, then I just want basically a default date time, which I believe is like the beginning of 1900 or something like that, based on the regular date time constructor. So anyway, so the behavior is going to be different if this approved is true versus if it's false. So here's where I'm using the 2 arguments in the second lambda again, where I'm passing both the faker and a reference back to the mechanic record with the other constraints applied. So in our lambda here, we check, I've got a ternary here. I check if approved is true, then I want to set a date in the past year. And if not, I just want to create an empty date time, default constructor, beginning of time, what have you. So the behavior here is going to be different if this approved was randomly generated as true versus if it was randomly generated as false. And then the last thing is the mapping of the mechanic to the user. So another interesting one. So I made this user gen up here, but we haven't actually used it yet, right? So whenever I specify the user, and I'm just using EF core convention here, so when I specify the user, which is this right here, whenever that user record gets created, it's also going to populate this user ID for the mechanic record. So I'm just specifying the user, and I am specifying it using my usergen.generate. So this will generate a random user, which is mapped against this mechanic. And so each time it generates a mechanic, it's going to generate a single corresponding user as well. Does that make sense to everyone? Okay, so same thing as when we generated the user above. The only thing that we need to call generate on here is the mechanic, because when it generates the mechanic, it's going to generate the corresponding user. So for mechanics, I don't need a large pool of them for my test cases and for my demonstration purposes. I only really need 100 of them. So I'm just generating 100. Same thing as above. We add DB context, our mechanic table. We're going to add a range, and it will be those 100 mechanics. So again, the .generate call produces a list of whatever the generic type is. So that in this case, it's going to be a list of mechanic. And we add that to the tracking for EF core. We save changes, and so that's going to generate 100 mechanics and 100 user records that map to those mechanics. So again, same thing. This is set up in my seed controller for seed mechanics, and similar route, just seed mechanics at the end. So let's go ahead and run that now, and we'll see what the output looks like. Mechanics seeded. Okay, let's go back to our database. Let's take a look at mechanics. Okay, yeah, totally random phone numbers. Yeah, no formatting whatsoever applied, just as we wanted. Qualifications are paragraphs of lorem ipsum, a single paragraph of lorem ipsum each. Approved is randomly 1 or 0. If approved is 0, you'll see that the approved date is the beginning of time. That's and we may go back and make this nullable and actually put in a null value here instead of a legitimate looking date time. But the point is, if approved is 0, then this is not a field that's considered, so it gets set to garbage. But if approved is 1, then we get a random date within the last year. And you'll see these are all tied to user IDs. And interestingly, starting with the 1001 record in the users table, which makes sense because we already injected 1,000 users, and now we injected another 100 on top of that. And since we're auto incrementing and starting at 1, we would expect this to be 1001 to 1100. That's our 100 user records. And now let's look at the users table to verify that as well, if I can find it. Okay, yep, 1,100 rows, that's what we expected. And if we scroll down past the first 1,000, then you'll notice that now, starting at record 1001, we have the role ID as 1 instead of 0 as we specified. We still have random names, email addresses, everything is looking real good here. Enabled is still 0 because, once again, we didn't specify the behavior for that. And yeah, these are tied to the corresponding mechanic records. So if we need to find a mechanic's first name or last name, we can refer back to their corresponding user record and get it from there. Now, everybody following so far? Cool. Okay, so you remember at the very beginning of the talk here, I talked about the whole list items thing and related lists and how all that was going to be maybe a problem for us. That's kind of the first troubles that I ran into as I was building this out. I next wanted to seed vehicles. But the problem is I need to pick a random make from the list of makes, and then I need to pick a random model from the list that corresponds to those makes. So I don't end up with, say, I don't know, a Honda Sonic or something like that, a mismatched make and model. And it was funny, when I first ran this, the guy that I'm kind of working with on this project that I'm sort of building it for, I sent him a funny screenshot. It was was like a Cadillac Accord, I think, was the first one in the list. And I was like, well, something needs constraint here. Yeah, so anyway, let's talk about how I address that problem. So I'm using EF-Core. I go into my database context, list items, and I'm using a where to create an iQueryable, passing in a lambda here for the items in this list items table, and I want to constrain it to where the list ID is equal to the enum value of the make list type, which is 0. So this is only going to contain, or the eligible items for this makes list is going to be the entries in the list items table that have a list ID of 0, which is the makes. So that's good. Now that's not going to get anything else that it's not supposed to. It won't get the models. Then for the models, I'm doing the same thing. I'm creating an iQueryable using the .where link function, except my criteria in this one is I want where the list ID is the enum value of the model list, which is 1. So this is only going to get the full list of models across all makes. This is very important. This is not constrained in any way yet. So we've got the full list of makes and the full list of models as iQueryables. We haven't actually queried the database yet here. We can talk a little bit more about the EF-Core functionality in another talk, but the important thing here is that we've got all the makes and all the models in these pools, so to speak. And then just trying to remember what I did here. I probably should have thrown a comment here. I don't remember what the purpose of this min call was. It may have just been testing. And it does not look like it actually impacts anything. Yeah, so this is probably completely unnecessary. Anyway, let's get into the data generator because that's what we're interested in. So first thing is for the year, the rule for the year. Let me pull up the vehicle model here so that these have some context. So the vehicle's year, I'm going to say that any cars that we're going to be working on and were only made within the last 70 years. I don't think for the service that we're providing that we're going to be working on any classic cars or anything like that, and 70 is already kind of pushing into that territory for sure. So, so yeah, anyway, I just get a f.date, and we've seen this before, but before, so we were using f.date.past. I'm doing past 70 now, so it will be any random date in the last 70 years, but I only am interested in the year part of it. So I'm calling .year on the result, since past is going to produce a date time, and I'm only interested in the year component of it. So this is just going to be a random year between 70 years ago and this year. Now for the make, I am using the f.pick random function. Now this is one of the ones that's not in like kind of a subclass. Like we've got the f.phone, f.lorem. Pick random is actually f.phone.phone number, f.lorem.paragraphs, but with the pick random, it's a function that's right in the faker class itself. So f.pick random, the way that this works is you give it a generic type, which is what the random thing that you're picking is expected to be, and we're passing in our iQueryable list items makes. So this is going to pick one random make from this list and grab the value of that, which is where we actually reach out to SQL and get this single record that we're interested in. So we're not doing anything here that's terribly inefficient. So yeah, this is just going to get a random make. It's going to get the dot value, which again in my list items, each item just has each item within the context of a list has a value that is the value of that item. So this is just going to be a value that corresponds to an entry in the list items table for a make. Then for the model, this is where we apply that constraint I was talking about earlier. We're using pick random again, and we're picking a random list item. But this time, instead of just passing in this model's iQueryable directly, we're calling .where on it. And you'll notice that for the lambda call that we're using here in our rule for model ID, we are passing in both parameters, the faker and the reference back to the vehicle itself based on the constraints we've already applied. So we are now using a where query against model, which is, that's going to be each item in the iQueryable list of models here. And we are only interested where the parent value is equal to the make ID that we already selected. So we get our random make ID from the makes list, and then we look for a random model where its make is the parent value, which will tie, that'll make it so that whatever model we picked, we're going to get the corresponding make for the manufacturer that actually makes that vehicle. Color, weird one. The kind of namespace for that is commerce. I'm not sure why color is in commerce, but this is a design decision of Bogus. So I'm grabbing a random color here, and this is also constrainable, but I don't really care. I just want random color. The user ID, I am actually just picking a random user out of the database. That's all this does. So we're using pick random again. The type of object that I'm interested in picking here is a user, and I'm just passing the full database context.user table, so it can pick any random entry out of that table and get the user ID. So again, this is just going to pull one record, so nothing super inefficient on the database side. And that's all the rules for vehicle. So same thing as we saw before, adding a range, calling generate on my vehicle gen that I've defined here, and saying that I want 1,200 vehicles. So this is going to create 1,200 records in the vehicles table with all of this setup. So let's go ahead and run this one. We've got the same kind of thing in our seed controller. We've got a seed vehicles, so we'll call that. This one might take a little bit longer because we're asking for a lot, and there are a lot of references to this as well. But whenever it is finished, we would expect to see 1,200 distinct vehicles with appropriate makes and models kind of mapped together, and we can look at the database and see that and confirm that. So while we are waiting for this, does anyone have any other questions so far? Any thoughts? No. Okay, so our vehicles are seated. Let's go ahead and take a look at the vehicles table. Yeah, it looks pretty good. Now, I do want to see what these makes and models actually are, so I'm just going to write up a real quick query here. We're going to join makes on makes dot. The ID is 0, and makes dot value equals make ID. Items, we're interested in models on models.list ID. Again, the models list is 1. Value is model ID from the vehicles table. Okay, so we will do here, throw in makes dot name is what we want, and then also the models dot name, right? See if we did this right. Yeah, there we go. So like, there's a bunch of Acuras, there's a bunch of Audis in here, some BMWs, some Brilliants, some Bugatti. There's Chevy and Chevrolet, which I'm not sure whether those are two separate makes or two separate manufacturers, but Chrysler Sebring, Chrysler Voyager. It kind of looks like everything matches up here. Again, we didn't specify a behavior for the enable flag, so it defaults to 0. Everything else seems pretty sensible. Let's also bring in our user as well. Table name is actually user. Keyword, let's surround it here. Let's do, let's grab the first name and last name and email. Don't really care about anything else. Just want to make sure basically that these vehicles are assigned to valid users, and it does look like that's the case. Here's all the people. I think I did the constraints wrong on these list items tables because I'm seeing a lot of entries in sequence for the same person. But you get the idea that the data is generating the way that we would expect, and Faker's doing what we've asked it to do. So everything's looking really good so far. So the last one that I have, which is by far the most complicated example, is appointments. So this is another one where I ran into some issues. An appointment is it includes a user who's for that appointment. So the user that's associated with the vehicle is the owner of the vehicle, but there might be a different user associated with the appointment. So there's a user, let me pull up the appointment model, database model. Yeah, so there's a user, there's a mechanic that it's associated with who's handling the service appointment. It's associated with a specific vehicle. There's some other stuff that's directly associated with the appointment, but yeah. So when we create the appointments, there is a place in here, and I'll explain this in a second, where I need a random number generator. So this is not a Faker thing, or a Faker or a Bogus thing. This is actually built into the .NET built-in libraries, random for generating random numbers. So here is my appointment gen, creating a Faker of appointment gen. The first rule that I specified is status, and I want a random enum value, random integer value of an enum for the status, and let's see, here's my different statuses, kind of similar to what we've seen with the other enums here, where we're using the description attribute to give them a nice name in case we need it for UI purposes. But anyway, so we've got 0 for pending, 1 for in progress, 2 for completed, 3 for canceled, right? So I use f.pickRandom to get a random one of those enum values, and then of course can cast it to an int because I need this to be an integer for the field. The appointment date, random date in the past 5 years. We've already seen that. Vehicle, we're using pick random against vehicle and just getting the full list of vehicles from the database. We've seen that. Nothing kind of new here. The user ID, getting the user ID of the vehicle that we selected. That's kind of important. We want to make sure that we're not getting a totally random user here. It has to be the user that owns the vehicle. So that's where we get our user ID from. Appointment services. So we have these services, right? So this is a many-to-many relationship. We've got, here's the database model for a service. And then we've got this appointment services, which maps appointments to services. So one appointment might have one or more services, and one service might have one or more corresponding appointments. So this is just a typical many-to-many relationship. But it's interesting. I want to get some random services and add them into the appointment services table for this appointment record. But I don't want to reuse the same service twice for the same appointment. So you wouldn't obviously do 2 oil changes in the same appointment. So I don't want to repeat services within the context of an appointment. So that complicates how I'm going to generate these appointment services. Mind you, I'm not generating services. Those are a fixed list, and I think I already, let's see if I still have those up. I don't, but anyway, they're just called test service 1, test service 2. I've got 5 of them. Yeah, so those are statically set. I don't need to actually generate random services, but I do want to randomly select services for an appointment and map those in here, and I do want them all to be unique is the point. And there's nothing built into Bogus to create a rule where for each record generated it uses a distinct or unique value from the set. So I have to kind of roll that myself. And so how I do that is I create an appointment service list, which is just an empty list of appointment services. I'm going to get a random number of services. So this is where I'm using that random number generator that I specified above. I want a random number between 1 and 3, inclusive of both, obviously. So some appointments might have 1 service, some appointments might have 2 services, some appointments might have 3 services. So I'm just getting a random number here, and it's just an integer random number. Then I am using Faker here. I'm using the random property, which has a shuffle function. And shuffle, it will just randomly rearrange a list for you. So kind of like what we've seen with pick random, it takes a generic parameter that is the type that you're shuffling. So I'm shuffling my services, and that's constituted by db.services. So this is, again, database context, the services table. This will take any entry in the this will take all the entries in the services table, and it will shuffle them. And then I'm chaining on to the end of that a call to the take function, which anyone who's familiar with EF Core will recognize. This is just, I'm going to get X number of records from this set, and I'm going to do my service SVC count. So whatever random number is chosen here, 1, 2, or 3, that's how many records this is going to produce. So I don't have the type explicitly specified here. I'm just using var, but this is an IEnumerable of service. And then for each service in that list, I am adding to my empty list here of appointment services an instance that's produced by creating a faker of appointment services, setting the rule for the service specifically to the service that I selected, and setting this has parts parameter, and this is why I'm using the faker here. I do want the has parts flag to either be true or false randomly, so I'm using f.random.pool here to specify true or false random for whether or not they have parts for this appointment, and then calling generate to produce a single instance of appointment services. So iterating over the service, iterating over the shuffled list of services, and for each one in there generating a single appointment service using that service and a random Boolean value for whether they have parts or not. And of course I return that from this lambda, which is going to assign that appointment service, those appointment services that were generated to the appointment services property of the appointment. So I realized that one was a lot more convoluted. Does anyone have any questions? I will take that as a no. All right, so I mean, this is the last one. Let's go ahead and run it. And this one may not. Okay, yeah, we did already set this up, but I don't know that I've actually tested this one yet, so I'm not sure if this will truly work, but we'll give it a try, and we'll see if we can generate some appointments here. I mean, obviously, when this is going to take a little bit. We are asking a lot again. Well, this is going. I think this is okay. Yeah, I was afraid that this was going to happen. It's probably just a timeout, but let's take a look. I probably missed a migration here because saying mechanic ID isn't a valid column. But if that wasn't the case, then this would work and would generate service appointments and appointment services as expected. Yeah. So does anyone have any questions in general about Bogus or the Faker class? Any questions about use cases, thoughts on other use cases that I haven't specifically mentioned? Yeah, let me actually pull up the documentation here. Pretty sure they have. Yeah, so like here's like the API list. So like for social security number, I think that falls under. It's not name. Probably random. Yeah, there's okay, bogus.person.ssn for a U.S. Social Security number, also bogus.person.sin for a Canadian social insurance number. There's the United Kingdom, Portugal, this is very internationalized. It's got everything. One thing that I didn't notice. So I might not even have to do all of my fun stuff with the manufacturers and models, because it turns out that you can randomly generate those too. Missed that. Even fuel type. Yeah, that's why I said I didn't really want to cover everything. You can refer to this documentation yourself. It's right on the Bogus GitHub page. They've got a lot of different things a lot of different data sets that you can get random data from. So there's all sorts of cool stuff in here. Anyone have any other thoughts or questions? All right, well, I will take that as a no. So thanks for jumping on today, guys. It's great getting back into the swing here with Toolbox, and looking forward to the next talk. It's not scheduled yet, but I would imagine it's probably going to be about 2 weeks out. And I do believe that we will be returning to our talk on software testing, taking a look at some unit testing with XUnit, talking about using suitable data, which is somewhat related to this topic, for test cases, and kind of how you can use inline data, how you can use lists for data, how you can the difference between facts and theories in XUnit. A lot of stuff to cover there. Definitely a lot of ground. It'll probably be a longer talk like this one was, but yeah, it should be a lot of fun. So I'm thinking that'll probably be about 2 weeks out. All right, so thanks again for joining us today, guys.